everyone, my name's Rob from RobOps, and today we're going to walk through turning our manual AWS setup into a push-to-deploy pipeline. This represents part 3 of our 3-part series on building a website from scratch. Today's video will be focused on automation. First, capturing the AWS components we built in part 2 using Terraform. Secondly, we're going to wire up GitHub Actions so a push to GitHub will build and sync our static files to S3. Finally, we'll automatically invalidate our CloudFront cache so that viewers are able to see our website changes immediately. At the end of this video, we'll show how much faster automation is in the full development lifecycle of our website. As a quick refresher, we have a Next.js front end hosted on S3 with a CloudFront in front and Route 53 pointing our domain at the distribution robopslack.com. Today, we'll make all of this reproducible in a single click. If you skip part 1 and part 2, you can still follow along. Links to the previous videos will be available in the description and the pinned comment. As always, all of the code that we're going to create in this video will also be included with the specific PRs that highlight the changes that we made during this video. Now that we're in the code view, let's walk through the Terraform I've written ahead of time. We're going to go through all the steps and modules and apply it together. You'll notice all of the Terraform is stored on the _infra directory under Terraform. If you go to the variables file, you'll notice I've parameterized the basics, project name, domain, and region, so this is reusable for dev, staging, and production environments. If we navigate to the main TF, we'll notice that I'm using an AWS provider pinned to my region. State is also stored remotely in S3 with DynamoDB lock, so the whole team shares one source of truth. This is also beneficial when we run Terraform from our CI and locally. With a remote state, we'll be reading from the same source of truth. If we scroll down in our main.tf, we'll notice several modules for S3, ACM, CloudFront, and DNS. Our modules are abstractions of our implementations of the infrastructure in our modules directory. We have our S3 module that has a main.tf, an output.tf, and a variables.tf. And I look into the main. It's essentially creating an AWS S3 bucket. It's enabling versioning, and it's setting public access to off. Similarly, it's also ensuring that the ownership controls are set. Now, these represent all of the things we clicked through in the console, yet now they're defined in Terraform. Similar to S3, our CloudFront distribution is set up. The top 2 resources define important pieces or configurations for our CloudFront. The first is our origin access control. As you can remember, we went back and edited this in our part 2 of our video to enable origin access control in our CloudFront. Second resource is the CloudFront distribution itself. As you can see, it's quite a big resource, and the reason for that is CloudFront is a pretty complex service. However, a lot of these represent defaults. There are certain things that I would draw your attention to that we customized as part of our implementation that we can look through now. One of the most notable things is the default root object. As you can remember from part 2, we set this to index.html of our front-end site file. If we go into the variables and we look at the default root object here, we can see that it's pointing to our index.html. Similarly, the origin in which our CloudFront will point to is the S3 bucket we've created in Terraform. Finally, another key piece of information is when we've set up the origin access control, CloudFront actually generated an IAM bucket policy for us. If we scroll down to the bottom, we'll see that we define this origin access policy document as a data object in our CloudFront main.tf. And we apply that policy to our bucket. Moving to our certificate manager, we'll notice it's pretty straightforward. We define simply just the certificate. If we go over to Route 53, on the other hand, and we look at our main.tf, it's a bit more complicated. And the reason for that is because we have to go through the validation process of our certificate. If you'll remember from part 2, this involved creating the CNAME record within Route 53 from the ACM console. This process defines a validation object and applies that validation object to our ACM certificate. This will essentially issue us a certificate for our domain. Similarly, we create alias records, or A records, for the reference to our CloudFront. Now that we've gone over that, we're going to actually go ahead and look into how we actually apply this infrastructure. If we go back to our main.tf, we'll notice references to our modules here. This is simply saying, I want to use the S3 module that deploys our private bucket. I do need to provide some details, in this case, a bucket name, and I'll always need to reference the source of the module. In the case of our S3, we just simply have to create or provide a bucket name. In our case, it's just going to be RobOps Live Site Bucket. For the ACM module, we need to provide a domain name and alternative names. And if you'll remember from the start of this video, these are top-line variables that we've assigned. In our CloudFront, we define our source module and we've provided a name, in this case, my CloudFront distro. We do have to assign it a few different details across S3 and our ARN, or ACM module. As you can see, we've defined this module object and selected these identifiers. Terraform will automatically pull this information from the outputs.tf of our modules and allow it to be accessible in our main.tf. In a similar way, our DNS module, which was just our Route 53 module, is referencing several top-level domain variables, as well as some modules, and some local variables. Now, locals, when it comes to Terraform, are simply local references that we can create within our Terraform files. Here, we're creating our Terraform, our CloudFront aliases, and we're creating an ACM validation map. You can use locals as you need to provide more distinct values for your inputs to your modules. So now we're going to get on with the apply. Before we actually start to run any commands, I want to go over two key files in our repository structure: the backend config.tf backend and the terraform.tf vars. These two files are important for distinct reasons. Our backend.config.tf backend is what is going to initialize our remote state. Like I was explaining in the beginning, we're using a remote state so that both local development and CI/CD workflows can reference the same set of infrastructure. Here, we define our bucket, which stores our Terraform state, the key in which it lives under, the region, along with our lock table in DynamoDB. Moving over to the terraform.tf vars, this is what's actually defining those top-level variables that we mentioned before. Our domain name and subject alternative names are both robopslive.com, and our hosted zone ID is our hosted zone ID that we can pull from Route 53. These can be sensitive variables, and so sometimes it's not ideal to commit these to Git or to save them, and so keeping them in the terraform.tf vars allows us to protect the secrecy of these values. Now with that said, let's get on to the applies. So I'm just going to open a terminal window for my RobOps web project, and I'm going to go into the infra directory and then the Terraform directory. First, I'm going to run Terraform fmt to format anything that I might have missed, and then I'm going to run Terraform init-backend config equals backend config.tf backend. And so what this is going to do is just going to initialize our Terraform and use our backend config. This isn't required since the backend config is located in the same directory we're running Terraform init from, but in case you're doing it from a separate directory, this would be required. So I'm going to click enter, and this is going to initialize our backend. Now that our Terraform has been initialized, I'm going to run a Terraform plan. This is going to show all the resources that will be created. If I scroll up, we're going to add 15 resources across S3, CloudFront, and other various DNS records. Now that I'm okay with this, I'm going to run Terraform apply. And it should run our plan, and I'll say yes to perform this action. Now our resources are creating. Amazing. Our apply completed successfully, and we've added 15 new resources. Now, I can quickly show what would actually happen if we tried to access robopslive.com from our browser. If I went to robopslive, we'd simply get an access denied, and this is expected. We actually haven't uploaded any of our static files to this bucket. So in the next phase, we'll actually go through the steps of automating how we get our site files into our bucket. But before I do, I just want to reiterate what we've done here. In our last video, we clicked through setting up all of our infrastructure, And in this video, we've created all of our infrastructure and defined it in code. If I needed to come into my CloudFront and change the origin object that we reference from index.html to something else, I could just go into the variables file and change it and reapply, and our infrastructure would reflect what's defined in this code. In addition to that, all of this infrastructure would be on GitHub, where our teams could collaborate and change things together. With that being said, we're going to hop over to the second part of the video, which is going to go over the GitHub Actions that we'll create to automate the deployment of our site files. So now we're going to go over to our GitHub folder, and under the workflows directory, we're going to have two files. One for deploying our infrastructure, and so this is going to allow us to easily apply this Terraform in our CI/CD, and the other is going to deploy our site changes. Now, if I go to the deploy site change YAML, I'll notice we have essentially some instructions that our GitHub action is going to follow. It's going to run at any time we push to the main branch, and it's going to deploy our website changes. And so in order to do that, it's actually going to do the steps we did at the beginning of this video all automatically. So it's going to check out our repository, it's going to set up a connection to AWS, and it's going to ensure that it can use Node.js for our Next.js application. It's going to install all of the dependencies of our front-end application, and then it's going to build the site by running the same commands we run locally, npm run build. Then it's going to copy the files from our out directory to our S3 bucket. Then it's going to run an invalidation on our CloudFront to basically ensure that any of our old files are no longer referenced by CloudFront and we're only looking at the new files. As we mentioned before, there's currently no site files in our bucket. We're going to make a small change to our application and we're going to see how long it takes from the time the code is merged to the time it's reflected on our website. So to do that, we're going to hop back over to our AWS console and we're going to be in the site live bucket that we created with our Terraform. As we can see, the bucket's empty. If I open a new tab and try to go to robopslive.com, I'll notice we get access denied because there's nothing in there. And so now if I'm going to go back to our full screen view, I'm actually going to make the same, or at least reverse the change that we made at the beginning of our video. So here I'm just going to clear the terminal and I'm going to say git checkout main branch, git status, and we have a clean branch. Now I'm going to go into our app and then into the page. And before where I put hello platform engineering, I'm just going to remove it and click save. I'm going to commit this to Git directly to the main branch. So I'll say git commit -am, changing small typo. And I'm going to run git push origin main. Now we've pushed the site file to our GitHub account. And if I just try to track that file down by going to our repository here and going to action code, I'll see we've recently committed that change, small typo fix. And if I switch to the screen, I'll see small typo fix with a pending GitHub action run. So now if I open this up, I'll be able to see that our GitHub action to change started 29 seconds ago, and it's currently building our site. We'll wait for this to finish and see how long the run takes. Now, our run finished in 40 seconds. And if I go back to the robops live file that was currently access denied and refresh, we'll load our working website. As you can see, instead of at the beginning of the video where it took 4 minutes, it now takes us 40 seconds with automation. As we conclude this video, we can see that when we applied automation, the change that took us 4 minutes before took us less than 40 seconds, and it happened automatically. There's no risk of manual human error, and the steps are repeatable. Additionally, our infrastructure and application code is in Git, which means every change is versioned and reviewable. PRs tell you exactly what and why things have changed, And because it's reproducible, we can revert changes that had caused adverse impacts downstream very quickly and reliably. This is how modern development teams work. They eliminate any manual steps required to get the code from your laptop to customers. As we wrap up this series reflecting on what we've accomplished, we've created a front-end web page from scratch using Tailwind and Next.js. We've hosted that front end on AWS using S3, CloudFront, Route 53, and Certificate Manager. Then we've taken that infrastructure and captured it in infrastructure as code, otherwise known as Terraform. This allows us to recreate our environments easily and eliminates any manual steps involved. We also automated how changes to our website can get pushed to our website that is hosted on the internet. This was done using GitHub Actions. As we wrap up this video and this series, we will have an end-to-end flow for how we can develop and iterate quickly on our website. And as always, if this is a video that you enjoyed watching and if this is a series that resonated with you, please consider liking and subscribing. It really helps out my page. If you want to engage in discussion with me, please join my Discord page. If you're interested in any of the code that we talked about, it's all available on my GitHub page. And if you're interested in more long-form content or reading, I post blogs on my website at robertdipolito.me. Thanks again. Appreciate all the support I've been receiving on these videos, and I hope you all have a great week.